If you've ever wondered what factoring quadratic expressions has to do with, well, Maury and the You're Not the Father bit, you're in for a treat. This video is for you.
Class A. I'm telling you, a classic case of he said, she said. Shamika says this man Bobby's the father of her 3-year-old son, Jalen. Bobby says there's no possible way he's the father.
This is not your typical math video.
Shamika says she and Bobby were in a committed relationship.
In this video, we are going to be factoring quadratic expressions like ax squared plus bx plus c when a doesn't equal 1.
Bobby says Shamika was hardly more than a one-night stand.
We're going to be talking about the birds and the bees and all kinds of freaky stuff. So, man, I just want you to be ready.
And Bobby, if you're the father, this is your only son, so you would take care of him, wouldn't you?
I take care of my kids.
Absolutely. Yeah. Okay, here we go. When it comes to 3-year-old Jalen, Bobby.
In order to factor quadratic expressions, you have to know where they come from. Well, where they come from is a pair of binomials that meet up and fall in love, and then the expression is multiply by rabbits. Well, for good reason. See, we've got these two binomials right here, and they're going to kind of meet up and bump into one another, and then, well, lo and behold, we get a baby. Huh. So let's talk about the birds and the bees. Here are the mechanics of, well, binomial reproduction. See, what this means is everything in here is going to be multiplied by everything in there because they're right up against one another. So the acronym that kind of guides us through that, FOIL, stands for the first two. The first thing in this group and the first thing in that group get multiplied together. Then the outside of the entire thing gets multiplied together, the insides get multiplied together, and then the last two get multiplied together. And as it works out for these quadratics, the outside plus the inside can be added. So that's how we end up with a quadratic expression like this. So here's how it works in case you don't see it. We've got these two numbers right here that multiply together to make 3x squared. We're going to call them the mother. Then we've got these two right here. They multiply together to make the C term, the 2. We're going to call those the father, all right? Since there's only one way to get 3x squared, 3x times x, well, that means the mother's easy. See what I did there? Now we got to figure out, how do we get 2? Now there's two possible ways. It could be 2 and then 1, or it could be 1 and then 2. So we got to figure out which one's the daddy. And the way we do that is we take a look at the outside plus the inside. Now, if that equals our b term, which is 7x, then that would be the dad. This one equals 5x, so that's not the father.
You are not.
This one over here, though, outside is 6x, the inside is 1. That makes 7. That's the dad right there. That's the father. You've got to remember that a quadratic equation, if it can be factored, it's the product of two binomials. And there's kind of two cases. Here's the first. Now this is kind of ugly and it might be kind of confusing, but if a is 1, all you're going to do is look for two numbers that multiply to make this, and the same two numbers add to make that. That's what all this says right here. And you can see that works right here. 3 times 5 is 15, and 3 plus 5 is 8. It's a little uglier, though, if the first term isn't 1. Like here, 2x squared plus 19x plus 35. Well, the outside is 14x and the inside is 5x. And, well, that's kind of how it works. You see, 2 times 1 is 2x squared, and 5 times 7 is 35. And then you do the outside plus the inside. That's how you get the b term. So what we're going to do when we're factoring this is we are going to guess what the mother is, and we're also going to guess what the father could be, and then we're going to check. We're going to check the outside plus the inside. And if the outside plus the inside equals b, we found the dad. So let's play. Let's see who's the dad right here. Here's what we're going to do. We're going to guess, and there's only two guesses for the mother, 5 and 1. So 5x and 1x. Now the dad, two possibilities. It could be 1 and then 7, or it could be 7 and then 1. So let's go ahead and check the outside plus the inside. Here we got 36. Over here we got 12. You're not the father. Why? Whereas over here, this is right here. That's our answer right there. Now, by looking at the baby, we can actually get some clues about the parents. All we need to do is look at this last term and see its sign. You see, if the sign is the same, if they're both if it's positive, then both of your factors will be the same sign. Like this, right here. See? Both are the same sign, and, well, the reason this is positive is because a positive times a positive is positive. And the product of two negatives is also positive. But if you add two negatives, you end up keeping a negative. So, anyway, if this last term is positive, then your two factors are going to be the same sign. Whereas, if the last term is negative, then you have different signs for your factors, like this. So let's see. On this one, what we've got is 5 is positive. That means the two factors have the same sign, and they add up to make a negative 16, so they're both going to be negative. So here are the two possible combinations. Let's check the outside and then the inside. And we're looking for a negative 16. So this is it right here. There we go. Man. All right. Now this one's a little bit uglier. You see, this is negative, which means our two factors are negative. And we cannot tell ahead of time which way it's going to be. But I know it's going to be, the mother's going to be 7 and 1, and the only factors of 11 are 11 and 1, so it's just the way we arrange it that's going to tell us which is right. We can't go ahead and figure out which is positive or negative, but we know they're different signs, and if they're different signs, you're going to be subtracting, so we're just going to find the difference of the two. All right, so when we do this one here, 7 and 1 and 11 and 1, well, the difference of those is 4. And over here, the difference is 76. Well, we need 4, but we need 4 to be negative, so the 11 is going to be negative, and the 1 is going to be positive. And there's not really a shortcut for this. You just got to take your time and figure it out. Okay, let's look at another one right here. Now, this one, because 8 isn't prime, we have quite a few options. Boy, a lot of possible baby daddies here. Not cool. Whoa, that's a little over the top. Anyway, let's check the outside plus the inside for all 4 of them. See which one it is. You can see right there we are looking for negative 10x because that's what the B term is. So this is it right here. That's the baby daddy right there. It's all fun and games till someone loses an eye. And this last example, man, this last example is a little ugly because, well, the first term and the last term, they're not going to be prime, neither one. They're both going to be composite. And then we're also going to see what you're going to do if your first term, if the A is negative. All right, let's factor this quadratic. We know this quadratic will be the product of two binomials. And it's tricky because both the first term, 4, and 15 have, well, a pair of factors. Neither one is prime. So use a pencil. You're going to do a lot of guessing, and you're going to do a lot of erasing. So let's try 15 and 1 with 2. And, well, that doesn't give us 7, it gives us 28. Either way you do it, doesn't matter where the 15 goes. So let's try 3 and 5. 3 and 5 doesn't work either way. So what we know is we know that 2 doesn't work. 2 doesn't work at all. 2's not the mom. So let's try 4 and 1. Now we'll try 15 and 1 and we get 59, and you could switch it and you get 4 and 15. The difference of those is 11. That doesn't work either. So, well, 1 and 15 is not the dad. 3 and 5 is. We just got to figure out the order. So if it doesn't work one way, you just switch it, and then you try it until you get it. So there you go. 12 and 5, 7. Now, the sign, you got to make sure it goes in the right place, and you are done. Okay, let's take a look at one more example. Leading coefficient's negative. That's a problem. All these tricks and shortcuts and stuff don't work if it's negative, so you have to factor a negative 1 out of everything and then factor what's left inside. So what we have to factor is 9x squared minus 45x plus 50. But let's be smart about this. Let's not guess everything. There's so many factors. Let's just take a look. Let's try 3 and 3. If I try 3 and 3 and 1 and 50, well, 3 and 50 is 150. Signs are the same. I'm going to add. I can't start at 150 and end up with 45, and I can't start with 25. 25 times 3 is 75. So maybe it's 5 and 10. Let's try. 5 and 10. The outside would be 30x. The inside would be 15x, and that is 45x. So we are D-O-N-E finished. Wow. We deserve a smiley face. You ever notice you put eyebrows, it looks angry? Well, I hope this video was informative and maybe even entertaining. Let me know. Just leave me a comment. If you liked the video, click like, maybe subscribe. Visit my website, thebeardedmathman.com, where, well, you can find all kinds of fantastic mathematical information. Anyway, thank you for watching.